Okay, so recording has started. Good afternoon. Today we'll be talking about estimation of mechanical projects. Mechanical projects are divided into two, or sometimes they are combined into one: mechanical ducts and mechanical pipes. For mechanical projects, what we usually consider are ducts, floor-mounted equipment or equipment, suspended equipment such as fans, shield beams, ERVs, those what we considered for suspended equipment, and I think I've mentioned mechanical pipes. So that's what we measure for the estimation of mechanical projects. So let us start. I will start sharing my screen. We have a sample project here. It's Augusta B108. I prepared the files here. So the first thing you would want to do is you should confirm with Arash, since Arash is the one handling the estimation projects. Confirm with him how many files does this project have, how many folders, so on and so forth. So usually he's the one who's uploading the files. So you should confirm with him how many files are you going to work with. Okay, so these are the files. What you would want to do first is you would give them a scan. Give them a scan. So these are all the files. What we usually do is sometimes what we do is we take only the plans that we need, but for our purposes and for to save some bit of time, let's essentially copy all of them, put them in SP proposal drawings, and this is usually the folder we work with, and this is where we would do our work. So as established, let's start here. Let's open this one, the fee proposal Excel. This is where we will be inputting our measurements. So this should be 0. This is where we'll be inputting our measurements. So for this one, there are no measurements here. So let's skip with that. This one, let's skip with that. And we can start here. So first general rule when we are estimating ducts, let's go to the Excel sheet. Okay, so what the most important rule you should know when you're estimating ducts is if it is less than 0.4 square meters, if the cross-sectional area is less than 0.4 square meters, it is not counted. That's the same for importance level 2 and 3 and importance level 4. Additionally, I'd like also to add, importance levels are usually not included in the estimation stage. However, you can ask Arash or Peter sometimes, but mostly it's Arash for estimating projects. You can ask him what's the importance level for projects. Importance level plays a huge part in the estimating process, so make sure you coordinate properly. Sometimes they would put it in the planner, but sometimes they don't. But essentially, this is what you do. If it is less than 0.4, it is not included. But if it's greater than 0.4, you should include it. Sometimes the ducts can be circular in shape. If that's the case, if it's more than 700, it's included, and vice versa. If it's not more than 700, if it's less than 700, it is not included. So with that in the mind, let's start. This is HVAC and large floor plan, and let's start measurement. Let's scale. Sometimes I forget to scale as well, but Bluebeam does this. It has this feature when if you forgot to scale the page, it will notify you that you need to scale it first, which is an amazing process indeed. So I've mentioned earlier that if it's less than 0.4, obviously for this area, it's less than 0.4. However, it is along the run where the duct is more than 0.4, 1.2 by 0.6. If you multiply that, that is more than 0.4. And it is attached rigidly to this one. If you have rubber joints here, you can disregard it. or consult with Arash if they want to put it. But since it's attached rigidly to this dock, it is not. It is included. So it is included in a straight run. You can put this and that. So I'm not sure this one as well. Okay, so if that's the case, with this legend, we will tackle this later. There's like a separate page for this one. We will tackle this one later. This is 33.09. Okay, so let's fill this one up. What I like to do for this column, instead of level, I put page here since it's easier that, so say for example, this one. Say for example, this one. The concern here is it's the same level, but it's divided into pages, and it's easier to organize your estimates if it's per page instead of per level. So in that case, let's use this one, HVAC and large floor plan. HVAC and large floor plan. As you can see, it is near a structural wall. I assume that it's near a structural wall because of the concrete hatch. If you use CAD, I'm pretty sure you're familiar with this hatch. If it's not, you can assume that it's not a structural wall. But for some cases, you know that it's a structural wall. Say, for example, if it's near an elevator wall or if it's near a staircase wall, which is sometimes structural, then it's a structural wall. Otherwise, do not assume it's a structural wall. This one is pretty obvious because of the concrete hatch, but otherwise do not assume unless it's, as said, elevator walls. So those are structural. So we have the measurement, 33.09. 33.09. It's next to a structural wall. The complexity factor, let's go back to the notes. Complexity factor, essentially, this is per your own judgment. If it's mostly straight runs, it's 1. If it has a little bit of complexity, it's 1.2. If it has like multi-clashes, many clashes and bends, then it's 1.3. From my understanding, this is 1. And the dock size factor, this does not exceed the 0.8 threshold. What I'm talking about, the 0.8 threshold, is this one. 0.4 to 0.8, 0.8 to 1.2, and then it's more than 1.2. So 1, 1.1, and 1.3. Mostly it's 1. So here you have 2 runs. But since this is more dominant than this one, I would say it's the 1. So it's 1 for the complexity factor and 1 for the dock factor. Let's tackle this one later since it's referring to another page. So for clearing that, oh, I forgot. There are no suspended units here. Number of pages is 1. This column is for when it's repeated. If it has a similar layout on to other levels, then it's repeated. And next. Okay, we can start working on this. So here we have fans. We have fans and we have suspended ones. Oh, actually, yeah, we have fans here. Okay, so this is what we usually do. These are like the cassette type AC units, and what we do is we suspend them as well since they are susceptible to falling in the event of an earthquake and they might injure someone, so we restrain them. As discussed earlier, this is less than 0.4, therefore not included, be it importance level 2 or 3. And these are small fans. So let's do some counting. And you have suspended units. So these are floor mounted sieves. So let's do some counting. Oops, where is my legend? Okay, so let's go back to the Excel sheet. This one, they have the same name. I'm just gonna do 1 and 2. Okay, so we don't have to count anything here since it's small. So this is blank. You can leave this at blank, but we have suspended equipment. How many of them? We have 5 of them. Small fans, I use this one. You can rename it, but that's for your optimization. So for this case, let's rename it. Let's put small fans here. EF or exhaust fans are generally small, so that's the case. EF. They are generally small. Let's put them. Let's put them here. Number of drawings, it's only one. Number of drawing pages, it's only one. So we are done with this page. The floor mounted CUs, actually, we're not done. Floor mounted CUs, let's do here. Let's go to the planner. Uh, Floor mounted estimate here. We can start with 5. Let's start with 5. We will show this to you later. 5 because there are 5 here, and the next is here. So as you can see, we have a 1.2 by 0.7 and this one as well. So let us start. This is 1 to 50. Okay, and let's start this one. Okay, so it's 7.47. Return doc. You can use the one from here. I'm just using this one since I don't want to rotate the page for our purposes. Usually the title block is oriented this way, but for this case, since this is the only drawings in this page, I can use this one. So yeah, I put return doc as here. So return doc 7.47. It's near a structural wall. It's near here. So that's no problem. Let's check the size. Let's check the size. 1.2 by 2. 1.2 by 0.7. 0.84. So the size must be 1.1. 5, 3, 1. Here 1.1 near structural wall. We have fans here. I'm not sure what this is. Okay, so this is a dedicated outdoor air system. Okay, dedicated outdoor air system. Okay. Okay, so we have 3 cracks here actually. I don't have a code for that, but let's put some. Okay, so we have like 3 crack units here. 3, so these are accounted for. This you have a CU here. Floor mounted CU, and we can assume that this is floor mounted as well. So we can include this. This would be the 6th, and actually we can include that one. That would be the 7th one. We have 3 cracks, so that is accounted for, and the length of the dock that should be calculated here is accounted for here. So we can move on to the next drawing. Here we can move on to the next drawing. Not this one, these are schedules. Okay, so we are now tackling mechanical pipes. Tackling mechanical pipes. Okay, so for mechanical pipes, mostly right now, we are dealing with refrigerant pipes. Refrigerant pipes are mostly connected to CUs or air conditioning units, and they are small in general. Why I'm saying small? It's by their design, and we have rules set for mechanical pipes. So let's take a look at them. Okay, so let's do kind of an inward style here, or let's say, let's check the ones that are not to count, because the opposite is we have to count them. So again, it is divided into two columns: importance level 2 or 3, importance level 4. As you can usually ask this to the project manager, and which is mostly Arash, since this is an estimating project. So our refrigeration pipes, usually they are small, and we do not count them on both levels. For importance level 2 or 3, if the pipes are singly hanged, take note, singly hanged, it's just singular, like this one. This is a good example. I'm not sure why it's cut, but yeah, like this one, it's a singly hanged pipe, and it's less than 65, importance level 2 or 3, you do not count them. Do not measure them. If it's importance level 4, it should be 25 or less. If it's more than 25, you have to count it. That's the rule. Importance level 4, these are for more delicate buildings, or I'm not going to say delicate, it's not delicate, it's for more, I would say it's for more important buildings. It's literally importance level. So that's the case. So the next one is for pipes sharing a trapeze. Our sample is this one. So when the pipes are sharing a trapeze less than 65, so let's say you have 50, 50, 40, 50. If they are less than 65, but they share a trapeze, you have to consider them if their weight is greater than 15. If it's greater than 15, you have to consider them. Same goes for the other one, but usually this has more. This is essentially for importance level 4. It just has more coverage. Now it includes pipe sizes 25 and less, Say for example, refrigerant pipes. Refrigerant pipes are usually small. If they weigh more than 15, you have to count them. You have to count them. So, how do we know that, hey, this group of 5 is more than 15? This is how we would do that. We have exemption rules on mechanical pipes. Okay, so these are your rules. So for mechanical pipes, we usually assume it's full of water and it is insulated. So we measure or we calculate the weight differently for plumbing and for mechanical pipes. We will discuss about plumbing later on, but for now, let's stick with mechanical pipes. Let's say you have an 18 mm or a 20 mm pipe. Let's say you have three of them, right? You have three of them, and then you add the support weight. You must never forget this one, because the client usually forgets this one, since it's not really in their prerogative, or it's not really, essentially none of their concern. However, for seismic purposes, it's essentially, we're technically restraining it as well. So we have to include their weight. So you have the weight of the pipes here and the support weight, which is 3.21. You add them together. My example here is you have a bundle of 20 mm, three 20 mm pipes sharing a trapeze. The total weight per meter is 8.67. So it's 8.67. It is less than 15. You do not restrain them. It is exempted. So going back here, 3.20, going back here, I think Peter made a slight exemption here, but for the others, he had some sample combinations. Let's say you have 240 mm and 232 mm, 250 and 220, and so on and so forth. He already made a combination here, or he already made a calculation, but usually this is a case-to-case basis. Sometimes it's 50-50 and 100-100. Sometimes it's like that. Sometimes it's another combination. So it's a case-to-case basis. So you should always check the weight. So that's how we do it. That's how we do it for pipes. For this case, we can assume that these are small. We can assume that these are small. Actually, they are here. So they're small. And that we already counted these, so no need to count them again here. And we are clear for this one. So let's move on to the other. Let's move on here. Okay, we already counted this. We assume that these are small. Okay, actually they are not small, but I think they are floor mounted. If the pipes are floor mounted, we can disregard them because since they are usually if they are floor mounted or directly fixed to the wall, which I think these are, we can exempt them. So you have CC. I think these are yeah, these are condensers. So you have three complex size condensers here. One, two, and three. And then we already counted this, so we're good with that. I'm gonna put them here. Okay, so okay, so let's go back to our sheet. For mechanical pipe, we have to consider one level. We have to consider this page. So refrigerant piping page. Let's put condensers. You don't have to measure anything here since the pipes are exempted, non-factors for this point, but you have to count the page since you're counting something here. So I think for this purposes or for our purposes here, we are done. We can move on to the app. Okay, so you're going to be inputting everything you got here into this page. So say for example here, total length of dock is 21. You input that here. How many suspended units? Suspended units, you have 5. And you have put 3 small fans here. Sorry, you can put 3 small fans. So okay, so but here, do not enter any words because it will, if you type letters here, it will trigger an error. So just leave them be. Next, you go to page estimate. Okay, minimal page, you do here. So minimal items is 1. Minimal items is 1. Very simple, nothing. And simple page is 1. Page is 1. No medium, so clear here. And if we go to the pipes, it's 1 empty page. So, oh, okay, I forgot to count this one. So page with minimal items should be 2. Okay, no repetition, no complex, so I think we're clear here. Okay, let's just do a count. Okay, and then light estimate. This is not an electrical project, so we don't have any lights. Estimate notes. Just put if, say for example, you have a riser outside or a specific room that needs concern, you have to put that here. Essentially, this is for special cases. But since this is a fairly simple project, we're not gonna put anything here. But if you need, you have to. So Appendix A. So since this was already a finished project, there's an existing Appendix A, but this is how you do it. So first, since my my PC is on a dark mode, I will be making it light mode. So let's do some light mode. Mm, Okay, let there be light. And here. Okay, for Appendix A, we'll be getting that here. This is how an Appendix A looks like. It's a pre-programmed page. Usually you have it when you have the project folder. It's usually already here. It's in this folder. And what we do here is essentially Appendix A is you telling the client that these are the documents wherein the estimate is based. Essentially, you will be grabbing their documents. And yeah, as I've said, this is the document that tells the client, this is where the estimate based, this is where our proposal is based from these documents. Okay, one thing to note about Appendix A is if you have drawings or if you have a set of plans and they are compiled in one document, what you usually do is you put, let's say, for example, HVAC overall floor plan has 8 pages. Here's an example. You put it here, you specify how many pages it has, and you put essentially in a black text. But since it's only one page, don't need to do anything. You only do that for drawings only. Sometimes the client will have specs, but you do not need to include the number of page for that. So we can move on here. It's page A1. Now, just a sec. Okay, so now there are times where your appendix A will need to have a second page. What you can do is just copy and paste this one, change this one, make this A2, and then continue, and then so on and so forth, A3, A4, A5. So that's how you do. Oh, oops, I can delete it. Why I can delete it? Okay. Delete. This is your appendix A. And since it's already done, you can upload it here. So just let's do, for example, it's save on my desktop. Okay. So then you put, actually, let's just put something here. So appendix A, essentially this is just appendix A, project name, client name. I'm gonna put sample here so that we know that this is just an example. So, and then you save. And then after you've done that, you ask your senior or you ask Arash to, hey, we finished this one. And if your senior is satisfied, then you can click submit. Or if he tells you that the estimate is good, you can click submit. Otherwise, you have to do some revisions. And if it's submitted, it will prompt something to Arash that the project is ready for his perusal and it's ready for his evaluation. And after that, we will submit to client. And if we win, then it's all good. But if not, well, you can't win them all. So yeah, but every time you do something like this, you get closer to winning. So yeah, let's move this one. So that's how we usually do design estimating for mechanical projects mechanical projects. I will be talking about the material takeoff next. So that concludes this tutorial.